Hey everyone, feeling that Kubernetes buzz, but not quite sure where to start? Well, you're in the right place. This deep dive is all about making Kubernetes click, especially for all you beginners out there. We're going to be breaking down this awesome book, Learn Kubernetes in a Month of Lunches.
Ah, yes. Learn Kubernetes in a month of lunches. Excellent choice.
I've been flipping through it, and it seems like the perfect roadmap for anyone who's, maybe feeling a bit lost in the Kubernetes world.
Yeah, absolutely. The book does a really great job of breaking down those complex concepts into these bite-sized pieces, just like the title says, learning Kubernetes one lunch break at a time.
All right, so let's dive in. First things first, what is Kubernetes really, and why is it such a big deal these days?
Okay, imagine you've built this amazing app, and now you want to run it everywhere, your own servers, the cloud, maybe even your friend's laptop, just to show off. Kubernetes is like this ultimate stage manager for your app. It handles all the tricky stuff, like deploying your app, making sure it can grow if it becomes super popular, and keeping it running smoothly even if something goes wrong.
That sounds like a dream come true, especially for someone like me who's more into building the app than babysitting servers all day. But there's this word that keeps popping up, containerized. What does that actually mean in the context of Kubernetes?
Okay, think of those giant shipping containers you see on cargo ships. No matter what's inside, clothes, electronics, whatever, they all fit neatly into these standardized containers. Containerization does the same for your app, packaging it up with everything it needs to run into this self-contained unit.
So my app becomes like its own little world, ready to be shipped and run anywhere. I'm starting to see why everyone's so excited about this. But where does Kubernetes fit into all of this?
Kubernetes is like the mastermind behind the scenes, orchestrating all these containers, making sure they get to the right servers, have enough resources to run properly, and can talk to each other if they need to. It's like the conductor of an orchestra, making sure all the instruments play in harmony.
I love that analogy. So Kubernetes takes those containerized apps and makes sure they run smoothly on any platform, no matter what.
Yeah.
That's huge, especially with how fast technology changes these days.
Absolutely. It gives you the freedom to move your app around without worrying about the underlying infrastructure. That's the real beauty of Kubernetes. It abstracts away all those complexities, lets you focus on your app.
This run anywhere idea is a game changer. Okay, but I gotta admit, all this talk about orchestration and containers makes Kubernetes sound pretty complex. What does it actually look like under the hood?
At its core, Kubernetes has two main parts. We've got the control plane and the worker nodes. Think of the control plane as the brain of the operation. It's making decisions about where your app runs and how it scales. Then you've got the worker nodes, which are the actual machines where your app's containers live and do their work.
Okay, so the control plane is the brains, and the worker nodes are like the brawn. But do my app containers run directly on these worker nodes? It feels like there might be another layer in there somewhere.
You are sharp. That's a great question. There's this thing called a pod, which is the smallest unit of deployment in Kubernetes. Usually a single container lives inside a pod, but you can actually have multiple containers sharing a pod if they need to work closely together. These pods are the things that actually get scheduled to run on those worker nodes.
Pods, got it. And actually, remember, the book has this cool diagram, figure 1.2, showing the deployment process. It's like this step-by-step visual guide to getting your app up and running on Kubernetes.
Absolutely. So imagine you have a YAML file. It's like a blueprint that describes your app and how it should run. You submit this blueprint to the Kubernetes API, which lives in the control plane. The control plane takes those instructions, analyzes them, and then tells the worker nodes to create the necessary pods, get your app running.
So it's like I'm ordering a custom coffee. I'd specify exactly what I want, the YAML file, send in my order through the Kubernetes API, and then the barista, the worker node, prepares my perfect cup of coffee, the running app.
Love that analogy. It really captures it perfectly. That YAML manifest, it's your way of communicating with Kubernetes, telling it how you want your app to be configured and deployed.
All right, this is starting to make sense. We have the control plane making the decisions, the worker nodes doing the heavy lifting, and those pods acting as homes for our apps. But I remember reading something that kind of blew my mind. You can actually run multiple containers in a single pod. Why would you ever want to do that?
Yeah. It might seem a little counterintuitive, but there are times when it's super helpful. Imagine you have a web application that needs to generate log files. You could have one container running your web app and another container whose whole job is collecting and managing those logs.
So they're like roommates sharing an apartment, each with their own responsibilities, but working together to keep things running smoothly.
Exactly. And just like roommates, they share the same resources, the same network, making it super efficient for them to communicate and work together.
Now I'm really itching to get these pods up and running. Is it as simple as clicking a button? How do we make it happen?
Well, not quite a button click, but it's pretty straightforward. Kubernetes has this command line tool called kubectl. Think of it like your remote control for your Kubernetes cluster. You use kubectl to issue commands, like telling it to create a pod based on a specific container image.
So I tell kubectl which container image I want, and it takes care of creating the pod, getting it running on a worker node. Pretty powerful stuff.
It is, but before we get too carried away, there's a key detail I want to highlight. Kubernetes itself doesn't actually run those containers directly.
Wait, what? That's a bit of a mind bender. I thought Kubernetes was all about running containers.
Well, it orchestrates them, but the actual execution, that's handled by something else. If you look closely at the container ID inside a pod, you'll see it's actually referencing a separate container runtime, like Docker.
So it's like Kubernetes is the project manager, and it delegates the actual task of running the containers to a specialist like Docker. That's an important distinction.
Absolutely. Understanding this relationship is fundamental for anyone new to Kubernetes. It's kind of like realizing the wizard isn't actually doing magic. They're just really good at directing the magical forces.
Okay, that analogy makes it crystal clear. So we've covered the basics of running containers in pods, but the book also talks about going beyond single pods and managing them at a larger scale. Is that where things get really hairy?
Well, it can get more involved, but Kubernetes provides some elegant solutions for managing lots of pods. Just think about it. If you're running a real-world application, you probably have multiple instances running to handle all the traffic and make sure it's always available, right? Trying to manage all those pods individually would quickly become a nightmare.
I can imagine that getting out of control pretty fast. So what's the secret sauce for managing multiple pods in Kubernetes?
That's where controllers come in. Controllers are like supervisors that manage the life cycle of your pods. One particular type, a deployment controller, that's especially useful for managing multiple identical pods, those that make up your app.
Deployments. Right, the book mentioned those. Even had a nice diagram in Figure 2.4 showing how a deployment acts as this manager for a group of pods. It's like having a team leader who makes sure everyone's doing their job and steps in if someone drops the ball.
That's a great way to put it. And what's really cool is that if a pod crashes or becomes unhealthy for any reason, the deployment automatically spins up a new one to take its place.
Hold on. So even if one of those pods goes down, the whole app doesn't crash? That's amazing. But how does the deployment know what to do? Does it have some kind of crystal ball?
Not quite a crystal ball, but it's close. This is the magic of self-healing in Kubernetes. The deployment is constantly monitoring the health of the pods under its control. It knows how many replicas, how many copies of your app should be running, and it'll automatically adjust the number of pods to keep that desired state.
This self-healing aspect is mind-blowing.
Yeah.
It's like having this invisible safety net for our application, making sure it stays up and running no matter what. But how does the deployment keep track of all those pods? It can't just be this random collection, right?
You're right, it's not random at all. Deployments rely on labels and selectors to manage their pods. Labels are like tags that you can apply to your pods, kind of like categories or keywords. Selectors, on the other hand, are used by the deployment to specify which pods it should manage based on their labels.
So it's like organizing your bookshelf. You label your books by genre or author, and then you can easily find all the books that belong to a particular category. Makes sense.
Exactly. Figure 2.9 in the book actually illustrates this really well. The deployment has a selector that matches the labels on its pods, so it knows exactly which ones it's responsible for.
And I remember this one mind-blowing example, Figure 2.10, I think it was, where they changed the label on a pod, and it actually detached from the deployment's control. Talk about the power of labels.
Absolutely. Labels are a fundamental part of how Kubernetes orchestrates everything, providing this really flexible way to group and manage resources.
This is starting to make a lot more sense. Pods, deployments, labels, it's all coming together. But we keep mentioning these YAML files, like the blueprints for our Kubernetes objects. Can we unpack that a bit for those who might be wondering what those look like and how they fit in?
Of course. YAML stands for YAML Ain't Markup Language, kind of a geeky joke, but it's basically this human-readable way to define the configuration of your Kubernetes objects. Think of it as a detailed instruction manual for Kubernetes.
And speaking of instruction manuals, I remember seeing this figure in the book, Figure 2.14, showing how you can even deploy these manifests directly from a web server. Talk about convenience, like having this central library of Kubernetes blueprints.
Exactly. YAML manifests, they're designed to be version controlled and shared, making it super easy to manage and deploy apps consistently across different environments. Yeah, you can think of it like that, a central library. Super convenient.
Okay, so we've got the basics of running apps in Kubernetes with these pods and deployments, but let's face it, in the real world, apps aren't isolated, right? They got to talk to each other,
Yeah.
exchange data, work together as a team. How does Kubernetes handle all that networking stuff? It's not like we're running Ethernet cables between those pods, right?
You're right about that. It's a bit more elegant than that. Kubernetes uses these things called services to give us a stable network endpoint for a group of pods, even if the pods themselves are constantly being created and destroyed by the deployment.
So it's like having a company phone directory, right? You can call a specific department even if you don't know the individual extension of the person you need to reach. The service acts as that central contact point, regardless of which pod is actually handling the request.
That is a spot-on analogy. Services abstract away all that dynamic stuff happening with the pods and provide this reliable way for other apps or services to connect and communicate.
This networking layer is super important for building robust apps in Kubernetes. It lets different parts of the system work together seamlessly, even as things change underneath. But speaking of changes, what about the data our apps generate? Containers are supposed to be temporary. So if a container restarts, all that data is lost, poof, gone. How does Kubernetes deal with that? It seems like a pretty big deal.
That's a really insightful question, and it's something that often trips people up when they're first getting into containers. You're absolutely right. If a container restarts, any data stored inside, gone. But Kubernetes has a clever solution for this, and it's called volumes.
Volumes. Okay, tell me more. This sounds like what we need to keep our data from disappearing every time a container decides to take a break.
Volumes are like these persistent storage units that you can attach to your ports. Think of it like an external hard drive that you connect to your computer. Even if you restart your computer, the data on the hard drive stays safe and sound.
I get it. So even if my container restarts or even gets deleted, the data in that volume sticks around. That's a lifesaver for any app that needs to remember things between sessions.
You got it. Data persistence is critical for a lot of applications, and Kubernetes has the tools to handle it really well.
All right, so we've got a good grasp on how to keep our data safe, but let's shift gears for a second. We've talked a lot about these stateless applications where the data is, well, temporary. But lots of apps need to store and manage data, like databases or message queues, things like that. How does Kubernetes handle those kinds of applications?
Excellent point. That's where stateful sets come into play. They're designed specifically for applications that have this stateful nature.
Stateful sets, right. The book made a big deal about those. It sounded like they provide this kind of stable identity and persistent storage for each pod, which makes sense if the data needs to stick around even if the pod gets moved or restarted.
Precisely. Think of it like managing a playlist. Each song in your playlist is like a pod. A stateful set ensures that the songs play in order, and even if you pause and come back later, it remembers where you left off.
Okay, that analogy actually makes perfect sense. So stateful sets bring this order and persistence to the Kubernetes world. It's like they're saying, hey, we get it, not all apps are the same.
Exactly. Kubernetes recognizes that different applications have different needs, and stateful sets are a great example of how it caters to those specific requirements.
All right, so stateful sets are the answer for data-heavy apps. But what about those tasks that need to happen on a schedule, like backups or running some kind of maintenance script? We used to set up cron jobs for those, but how does Kubernetes handle that?
Good question. Kubernetes has you covered with jobs and cron jobs. Jobs are perfect for tasks that need to run once and then complete, like a batch processing job. Cron jobs, on the other hand, are designed for those recurring tasks that need to be executed on a schedule.
So instead of setting up cron jobs on a bunch of different servers, we can define them right inside Kubernetes, and it'll take care of the scheduling and the running and everything. That seems way more efficient.
Exactly. It's all about centralizing and simplifying those operational tasks. Kubernetes provides that framework for managing those tasks alongside your other workloads.
I'm starting to see a pattern here. Kubernetes isn't just about running containers. It's like this comprehensive platform for managing every aspect of our applications, from the simple to the complex.
You've got it. And one of those crucial aspects is managing application updates and releases. It's one thing to get an app up and running, but how do we handle updates without disrupting users? That's always been a tricky balancing act.
Yeah, rolling out updates without causing downtime, that's the holy grail. And the book talked about this, how Kubernetes can do these gradual deployments, monitor their progress, and even roll back if something goes wrong. It's like having a safety net for those updates, which is super reassuring.
Precisely. Kubernetes gives you a lot of flexibility when it comes to deployment strategies. The default one is called rolling updates, where it basically replaces old pods with new ones gradually so your app stays up and running throughout the process.
It's like changing a tire on a moving car. You're swapping out the old with the new, but the car keeps going.
I love that. And if something does go wrong during the update, Kubernetes can easily roll back to the previous version, minimizing any impact on users. It's like having a rewind button for your deployments.
This is a huge deal for organizations using Kubernetes. It brings this level of control and predictability to deployments that we've always wanted but rarely had.
Absolutely. It allows teams to deploy updates confidently, knowing that they have the tools to minimize downtime and manage any risks.
And speaking of tools, we've mentioned Helm a couple of times now. Can we talk a bit more about what Helm is and how it helps manage those app deployments in Kubernetes?
Sure, Helm is a package manager for Kubernetes. Think of it like the App Store for your Kubernetes cluster.
So instead of messing around with individual YAML files for every single Kubernetes object, I can use Helm to bundle everything up into a neat little package and deploy it with a single command.
You got it. Helm charts make deployments super easy. They let you define all your app's configuration, dependencies, even the versioning, all in a structured and reusable way.
That's fantastic. It simplifies everything and makes managing those deployments way less intimidating.
It definitely does. And it's worth mentioning that Helm can even help with rollbacks, which is a huge plus.
So it's like having a time machine for our deployments. If something goes wrong, we can just jump back to a previous version, no problem.
Precisely. Helm keeps track of the history of your releases, so you can easily roll back to a known good state if needed.
This is an amazing combination, right? We use Helm to manage the deployments, and then Kubernetes has those rollback features built right in.
It's a powerful way to approach deployments, giving you that peace of mind that you can recover quickly if anything unexpected happens.
Okay, so we've covered deployments, updates, even rollbacks, all with this amazing level of control. But as our applications and clusters grow, monitoring becomes critical. How does Kubernetes help us keep an eye on everything and make sure those apps are running smoothly? We can't just cross our fingers and hope for the best, right?
You're absolutely right. Monitoring and observability are crucial for any production-grade application, and Kubernetes provides some really robust mechanisms to help us achieve this. There are two key aspects we should touch on: logging and metrics.
Logging and metrics, got it. Those are the cornerstones of understanding how our apps are behaving in the real world. So let's start with logging. Traditionally, we'd have to log into individual servers and dig through those log files, which was a nightmare, especially if you're dealing with hundreds or thousands of containers. How does Kubernetes handle logging in this containerized environment?
Kubernetes takes a centralized approach to logging. Instead of managing log files on those individual nodes, we rely on agents and external systems to collect, process, and store logs from all of our containers.
So it's like having a dedicated postal service for our container logs. Each container drops its logs in a designated mailbox, and the logging agent picks them up and delivers them to a central logging facility.
That's a brilliant analogy. It captures the essence perfectly. And this central approach has so many advantages: centralized storage and analysis, reduced operational overhead, and improved security and compliance.
This is a game changer for managing logs. It transforms logging from this tedious chore into a powerful tool for understanding what's happening in our Kubernetes cluster. But logging is only part of the story. We also need metrics to track the performance and health of our applications. How does Kubernetes handle gathering those metrics from our containerized applications?
Kubernetes offers this incredibly flexible approach to metrics collection, allowing us to use a variety of tools and techniques. One really popular approach is using Prometheus, which is this open source monitoring and alerting toolkit that works seamlessly with Kubernetes.
Prometheus, yes. The book mentioned that, how well it plays with Kubernetes. But for those who aren't familiar with it, could you give us a quick rundown of what Prometheus is and why it's so popular in the Kubernetes world?
Think of Prometheus as this data-hungry detective for your cluster. It's constantly scraping metrics from configured endpoints, and those endpoints could be your applications, services, even Kubernetes itself. It then stores all those metrics in this time series database. This lets you query and analyze data over time, spotting trends and potential issues.
So instead of relying on all these separate monitoring tools for different parts of our infrastructure, We can use Prometheus as a central hub to collect, store, and analyze all those metrics from our entire Kubernetes cluster. It's like having the single pane of glass for all our monitoring needs.
That's a great way to put it. And Prometheus's query language, PromQL, it lets you create these complex queries and alerts based on all the data it's collected. You can even visualize that data using tools like Grafana to create dashboards and graphs.
Now we're talking. It's like having a team of analysts constantly monitoring our apps and alerting us to any potential hiccups before they turn into full-blown problems. But let's not forget about security. As our applications and infrastructure grow, keeping everything secure becomes even more important. How does Kubernetes address the ever-growing security challenges in a containerized environment? It feels like a constantly evolving battle.
You're absolutely right. Security in Kubernetes is a multi-layered approach, and it's something that requires ongoing attention. It's not something you set up once and forget about. We need to think about securing the container images themselves, the network traffic flowing between our applications, and even controlling who has access to what within our cluster. It really is multi-layered, and it's definitely something we need to stay on top of. So one of the foundational security pieces in Kubernetes is role-based access control, or RBAC for short.
RBAC, right? We touched on that earlier. It's all about controlling who has access to what within our cluster, right?
Exactly. With RBAC, we can define very specific roles and permissions, both for users and for the applications themselves. We can determine who can create, delete, or modify resources. It's about making sure that only the right people or applications have the authority to perform certain actions within our cluster.
So it's kind of like having different security clearances in a sensitive facility. Not everyone gets to wander into the control room. That makes a lot of sense. But what about securing the communication between our apps? We wouldn't want sensitive information being sent out in the open, right?
Absolutely not. Kubernetes has us covered there too with something called network policies. Think of network policies as firewalls for your pods. They give you fine-grained control over how pods can talk to each other and to the outside world.
So we're not just relying on the security of the individual containers or the underlying network. We're creating this extra layer of security within Kubernetes itself.
You got it. Network policies let us create these rules that define which pods can communicate with each other, on which ports, and using what protocols. It's a powerful way to isolate your applications and reduce the risk of unauthorized access.
This is starting to paint a really clear picture of how Kubernetes approaches security. It's not just one thing, it's a combination of different mechanisms working together. But what about securing those container images themselves? We can't just blindly trust any image we find online, can we? How do we make sure that the images we're using are safe?
That's a critical point. Image security is essential, and we definitely shouldn't just trust any image blindly. That's where tools like image scanners come in. These scanners can analyze your container images for known vulnerabilities, malware, and other security risks.
So it's like running a background check on our container images before we let them into our cluster.
Exactly. And many of these image scanners integrate directly with Kubernetes, so you can scan your images as part of your deployment pipeline.
That's a huge relief. Knowing that we can catch those vulnerabilities early on is essential. Okay, so we've covered a lot of ground here today. The basics of Kubernetes, how to run and manage applications, networking, storage, security, and even some of those emerging trends that are shaping the future of the platform.
It's been a whirlwind tour of the Kubernetes landscape.
It really has. But, even after all this, I still get the feeling that we've only scratched the surface. There's so much more to discover and explore.
Absolutely. Kubernetes is a vast and constantly evolving ecosystem. But the good news is that there are tons of resources available to help you on your journey.
Right. And speaking of resources, we have to give another shout out to Learn Kubernetes in a Month of Lunches. It's been an incredible guide for us throughout this deep dive. And it's a perfect starting point for anyone who's new to Kubernetes or just wants to deepen their understanding.
I completely agree. The book does a fantastic job of breaking down those complex concepts and presenting them in this really digestible way, just like having a Kubernetes lesson over lunch.
And it's packed with those practical examples and exercises, which is so helpful for actually learning and applying the concepts. So if you're feeling inspired to dive into the world of Kubernetes, Learn Kubernetes in a Month of Lunches is definitely the place to start.
You won't regret it.
And on that note, we'll wrap up this episode of The Deep Dive. Thanks so much for joining us on this Kubernetes adventure. We hope you've learned a thing or two and maybe even feel a little bit more confident tackling this amazing platform. Remember, Kubernetes can seem daunting at first, but with the right resources and a bit of patience, you can master it one lunch break at a time. And hey, If we can do it, you can too. Until next time, happy coding.
Happy coding.